Now we're going to look at the problem set for today. This is the Module 3, Lesson 1 problem set. So if I have 3a plus 5a, that means I have 3 a's and I have 5 a's. So together, if I count these, 1, 2, 3, 4, 5, 6, 7, 8 a's. And that was the result that we were looking for. At this point, we are not verifying. We will do that in the next lesson. But for now, we're just going to expand and then come up with standard form for our answer. Okay, so 8b's minus 4b's would give you 4b's. 5c plus 4c plus c. So let's say this is camels. 5 camels plus 4 camels plus 1 camel would give you a total of 10 camels. It's important to know the coefficient when there's not one shown is 1. That's using the identity property of multiplication. So 5 plus 4 is 9 plus 1 is 10. 10c. 3a plus 6 plus 5a. So 3a and 5a are like terms. 3 plus 5 is 8. 6 is a constant. It's the only constant for this expression. So this is the standard form of this expression. These are equal to each other, but we are writing in standard form. Some people call that simplifying. But whether it's which way simpler really depends on the situation. Okay, and we have b and negative 4b. So 8b minus 4b is 4b. And then 8 is just a constant, and there's no other constants to combine it with. Next, we've got each of these has a c, so they're all like terms. We're going to combine them all. 5 minus 4 plus 1 minus 3. So 5 and all of that is times c. 5 minus 4 is 1, plus 1 is 2, minus 3 is negative 1c for your final answer. And now here I just kind of made my thinking visible by putting all of my coefficients here together and multiplying them by c. This time, on number 7, there are some a terms, and then there are some constants. So, 3a plus 5a, which is 8a. Then separately I have 6 minus 2, which is plus 4. Final answer, 8a plus 4, and that's in standard form. Again, let's see, here's some b and a b term, two terms that have b's. So 8b minus 4b is 4b. I like to use the color to make it stand out. And then constants have 8 and then negative 3. So 8 minus 3 is plus 5. 4b plus 5 is the standard form. Put in the way, sorry about that. Okay, here we go. We've got, again, all c's. 5 minus 4 is 1, plus 1 is 2, minus 3 is negative 1. I think that was exactly, that's fine. Number 9 and number 6 were exactly the same. That's okay. Now, next page. Again, we are not going to be verifying today. We're just not going to do that part today. So 3 groups of 6a would be 6a, 6a, 6a. This is expanded form. standard form. 6 plus 6 is 12 plus 6 is 18. And we're looking for our standard form where we combine all like terms. We're not verifying on this one. 5 times 4 is 20. D. Again, that's 4 groups of 5D. So expanded form, 4 groups of 5D. Just make that a little neater. 5D. Okay, this is standard form. Expanded, standard. We're not verifying, we're just working this out. Okay, 5 times negative 2 is negative 10 R's. Okay, and we've got some multiplying. 8 groups of 3B. 3 times 8 is 24B. Plus negative 2 times 7 is negative 14C. I'm not verifying right now. So this can be standard. See, I feel like this is standard form where we go ahead and we know that adding a negative is subtracting. This is equivalent. Either one of these is appropriate. I prefer this one. That's not an equal sign. Okay. Made a stray mark and it's... Oh, I cannot combine these because this is a B and this is a C. They are not like terms. Excuse me. Here we have negative 12S. And then 2, that's a negative T is negative 1T. So we need to remember when there's not a number written there, the coefficient is 1. So in this case where it's negative T, that would mean negative 1T. Alright, so that would be plus negative 2T, and then I prefer it minus 2T, just like this. Standard form. Again, this is also appropriate. This, and this are equal to each other. They are equivalent. Moving on. 9 times 4, or 9 groups of 4 is 36P. So that 9 groups of 4P would be 36P. Minus 6Q plus P. That plus P is kind of over here hidden, so don't overlook it. And remember that when you just have a variable, you've got one of those. Okay, that's 1P. The coefficient is 1. So I do have some like terms that I still need to collect or combine. That would be 37P minus 6Q. Standard form. Again, this, and this are equal to each other, but this is the standard form with like terms combined. Moving on to number 16. We would have 28G, 15H, plus negative 6G. We're not verifying today. Okay, so this is appropriate. I prefer to go ahead and write that as just minus 6G. Okay, moving on. Last 2 questions. Jack got the expression 7x plus 1 and then wrote his answer as 1 plus 7x. Is his answer an equivalent expression? How do we know? So, what we could do to see if it's an equivalent, we can use substitution. So we will do that. We're going to verify with substitution right now. And we just pick a number, any number we like. And we're going to say, for example, x is 2. So if that's the case, and I start with this, if I substitute 2 in place of x and work that out, so 14 plus 1 is 15, and then I do the same substitution using the same value for x, I would get 1 plus 14, which is 15. Since these are equal, then I know that he has equivalent expressions. Okay? These are equivalent. because I proved it by substitution. And I think the word that here is verify through substitution. Alright, so let's try the next one. We can use x is 3 here. We could have used x is 2. I'm just picking a value. So 7x plus 1, 7 times 3 plus 1. 7 times 3 is 21, plus 1 is 22. And the other one, 1x plus 7, so this is Jill. Substitute the 3. 1 times 3 is 3. 3 plus 7 is 10. So these are not equal, meaning these are not equivalent expressions. Because when I substituted a value for x, I did not get the same numeric value. And I should put yes, equivalent. Okay. Thank you very much.